Before we start with the evaluation process, let's think this from a business perspective. The objective of this problem is to avoid manual efforts where a person has to open the invoice, look into the values, and type it down in the system. Instead, we are going to train a model which is going to take the invoice as an input and extract the relevant key information. It is very important for us to understand out of n number of keys, how many keys we are able to really extract out of these invoices. For the first part of evaluation, we are going to focus on accuracy score, where we are going to perform key by key comparison. To give you an example, we have ground truth, we have prediction. We're going to compare the values one after another for each and every key. In this example, we can see we have 5 different keys and 4 of them are matching in the prediction. So this is one way of assessing the system where we can identify the accuracy based on the keys which are matching between the prediction and the rule. The output from this evaluation gives us an idea that how much effort is needed or how much effort is remaining for the person to fill out the missing information. However, this type of evaluation doesn't work well in certain scenarios. As we can see, the output of the ground truth is closely matching with the prediction. As you can see, most of this information which we have it in the ground truth is available in the prediction. However, the prediction also has some extra keys and extra information which we might not need or which might be incorrect. In these cases, accuracy might not be a great metric to evaluate, and hence we are going to do the second part of the segment where we are going to find out the precision in the recall. For example, let's take this case where we have only one row from the ground truth. However, in the predictions, we have 2 different outcomes. And these are the false positive cases where we have more number of keys than output. There might be instances where you have ground truth information and the prediction information. However, the values in the ground truth are not matching in the prediction, again resulting in a false positive. And there may be a case where ground truth has 5 keys and your prediction has 6 keys. Again, it is a false positive scenarios. There are also other scenarios where ground truth has more information. Say it contains 2 different menus. However, the model was able to predict only one of them, and hence it is losing some important information, which is our false negative scenarios. So identifying the precision, recall, and FN score for each and every key in this particular schema is going to be very vital for us to get an idea that how much coverage that we are going to get out of this particular. Let's go ahead and write some code for these 2 different segments. As we are going to compare the prediction and the output, I took an example where we have more than one menu item. So here we see we have 3 menu items, and again the predictions we have multiple menu. If we want to compare these 2 outputs key by key, it might be difficult because we have nested information, and hence I have created a utility function which is a recursive function. Given a dictionary, so this flatten dict, given a dictionary, let's say ground truth. Let's print the ground truth first. Ground truth of 1 is ground truth list of 1. So this is the dictionary where we have menu and the total segment. If we pass this dictionary to the flatten dict method, it basically flattens the entire dictionary inputs into one single level. So here we can see we have multiple menu items. So doing this process, it makes it really easy for us to perform a left to right comparison where we can have the ground truth, and similarly we can invoke this for prediction list as well. Say prediction list of 1 is going to convert all the nested lists into a single list. As we want to compare, let's go ahead and iterate prediction list or with the ground truth list. So for I in range of length of say prediction list, we're going to iterate the list. Let's say the ground truth to be ground truth list of I, and prediction is going to be prediction list of I, right? So now we have the nested information. Let's convert that to a flat dictionary by invoking this method flatten dict, pass in our ground truth, and again red flat is going to be flatten dict of spread, right? I'm just going to add a break statement for now. Maybe once we complete it for one item, we can run it for the entire batch. GT flat, comma spread flat, right? So these are the two dictionaries that we are going to compare, right? Okay, great. Now the next step is the comparison, right? So to do that, we are going to iterate through each and every key in the ground truth and check whether that particular key is available in the prediction. If the key is available, then we are going to compare the values, right? So the total number of keys will be the length of GT flat. So imagine GT flat has 10 different keys, then it's the total number of keys. So for key comma item in GT flat dot items, right? For every single input in GT flat, we are going to check whether this particular key exists in prediction. If else, we are going to get the value. If not, let's leave it as empty. To do that, spread value equals, we have to check in spread flat dot of get, dot get of key. We're going to look for the key. If the key is not available, then just return the empty string. Okay. In this case, like, so for example, now let me print this key and the key, the ground truth, the item, comma spread value. In this case, the item is the ground truth value. Right? Let's run this. Here we can see this is the ground truth value and this is the prediction value. If the key doesn't exist, then there should be empty string written here. Now it makes it easy for us to compare these two values. So if we have say, if the, let's call this ground truth value. If the ground truth value equals spread value, then let's say we call match keys equals 0. Let's do matched keys plus equal to 1, right? And let's create a dictionary here, say matrix dictionary or matrix list. We can keep it as list of dictionaries. And for every single invoice, let's have some keys. Say matrix dict equals this, and do matrix dict of, let's have invoice number. We don't have invoice number in this particular scenario, so let's keep it as the index I, and matrix dict of, say, total keys, which is the total number of keys in the ground truth. This is going to be total keys, and matrix dict of matched keys. It's going to be the matched keys here, right? And then we also need to compute the accuracy, which is going to be matrix dict of accuracy. Is going to be the matched keys divided by total keys, right? Right? Matrix list dot append of matrix dict, and just break. Now in the matrix list we have list of dictionaries. Right now we have the break statement, and hence it has only one, but once we remove this, it's going to run it for all. And what we can do is import pandas as pd, and we can do matrix df from to pd dot data frame of matrix list, and we can print this matrix df dot round up to, just to round up the accuracy metric to the set, right? Okay, yeah. Here we go. So invoice number 0, 11 keys, 2 keys match, and it has around 81%. Okay, let's run it for the entire batch now. Let's remove this break statement and let's run this. Now it's going to run this loop for 100 invoice predictions. And once we run this, we'll have the invoice from 0 to 99, which is the ID, the total number of keys, the matching keys, and the accuracy. Let's just find out metrics VF of accuracy, that mean. Okay, so on average, we have 68% of accuracy. However, it's not the case as we discussed earlier. This is just a number where we are trying to find whether the keys which we have it in the ground truth are matching with the predictions or not. We haven't accounted another important part where we have more information on the predictions. So let's move to the second segment where we will be deriving the metrics like precision, recall, and FM score, which is going to give us a clear indication about these false positives and false negative scenarios.